Oh no.
They're done, I think.
So just draw that much, please. As you're drawing, be prepared to answer, what have we drawn? Like, what are we representing by this drawing? Points for the whole room. Hands up if you know what's being represented. What's being represented by the drawing? Hey. So we've got 1, 2, 3, 4 subintervals. 2 points for that. What else are we representing by the drawing? Let's go, Lindsay.
A Riemann sum.
It's definitely a Riemann sum. 2 points for that. What else are we representing?
Left Riemann sum.
Left Riemann sum. So it's a left Riemann sum, and it is the integral that begins at x equals 0. This particular integral, we are ending at x equals 4. And we're integrating the function f. So we need to label the drawing here. So this red function we'll label as f. The green one we'll label as G. So doing a left Riemann sum, this is approximately equal to, we go to the left side of the subinterval, we have a 2, multiplied by the width of the subinterval, which is equal to 1, plus the next one, the value of f is 5. Plus then we move over to, let's see, 6. And finally, back to 5. So this integral would be 7 plus 6, so 7 plus 11, sorry, 18. So raise your hand if you notice we were doing a left Riemann sum here. Show me hand. 2 points for your hand is right. Okay. Question?
How do you look at it and know that it's left, like versus right?
Good question. So I look at the subinterval and notice that the value that they're using to indicate the height of the rectangle is on the left side.
Oh, you meaning of like each like step?
Right. So you look at each step, each subinterval,
Okay.
and I notice that the height of this rectangle is determined by the value of f on the left.
Left side.
And
So
that-
if it was at the 5, then it would be.
So if I'd done the right Riemann sum, the first rectangle would have looked like this.
So whichever edge of the column is touching the graph is whether it's left or right.
Correct.
Okay, and then trapezoidal is when it's like angled.
So trapezoidal, they look like little trapezoids. 2 points. Does that answer your question, Brennan?
Yeah.
Good question. Anybody else? Awesome. Hopefully this is simple. If not, we'll talk about it. Raise your hand if you know the value of dx for this particular Riemann sum approximation. What value of dx are we using? Just look at my calculations. Remember, when you do an integral, you're taking f, a value of f, multiplied by dx. And you just do that several times, and then you use the big S to add them all up. So what's the value of dx in this particular approximation, Danny?
1.
How many knew that it was 1? 2 points. You can see it on the picture too, because the width of each subinterval is the value of dx. Dx is change in x. Brendan, please.
Is 18 like the distance it's traveled?
Outstanding. So 18 represents 2 things. You need to memorize both. 18 is my Riemann approximation. Well, 18 is precisely this yellow area that I'm drawing right now. So 18 is this yellow area, which I'm now compelled to finish since it looks so nice. So 18 is the yellow area. Questions about that? We're using the yellow to approximate this red area. Apparently, red and yellow make orange. Kind of exciting. Okay, we're trying to find the red area, and the Riemann sum approximates that area. And if this graph F were a graph of velocity, then the red area would represent how much, it'd be the change in position to the right. During the first 4 seconds, the particle would have moved 18 spaces to the right. Must understand and memorize both of those, please.
So it's an approximation of the red area, but what is the red area called?
No special name for that, other than you could say
Is
it's
it like the velocity? Or
No. It's the integral of the velocity.
okay, it's the integral of it?
Lost somebody. Never mind. So the red is the integral of the velocity. It's the displacement of the particle. It's the change in position of the particle.
Okay.
No other names really. So. Please.
If we don't put an approximate sign like for the equation, will we get that wrong on the written side?
I don't think so. It is an approximation, but I think they'll be forgiving on that one. 2 points.
Yeah, I don't want to.
Oh, sorry about that. Other questions? Make sure you have that memorized. That's going to be tested over and over again. So, just go to the next box down. So on the same page, just go to the next, just a copy of the same graph. Let me erase this so we can start from scratch. Hold on. Let's use this one.
Wait, can you get rid of the blue dot?
Agreed. Here we go. Okay. So the intent of doing this right here was to help you remember the connection. That you know how to do a Riemann sum approximation of an integral, and you know that that integral is finding this area, and that this area represents change in position. Question. Okay, the new topic, which is the homework tonight, is simply finding area. So it's not a problem where they give a reason why you need to find the area. They're just old AP questions where they just say find the area. So it's you understanding how to use integrals to calculate complex areas. So it's not a real big step. It should be pretty easy based on what you already know. For example, if this problem had said, find the area in red, nothing special, you just do the integral of f. And that would find the area in red.
So they just want you to approximate it. They don't want you to like go any more like.
Keep going.
Like it's okay just to have it approximately 18.
So they'll specify as to how accurate they want the integral to be. So you don't have to worry about that part. So you just understand, hey, this integral is going to find me the area. Depending on how accurate they specify, I can find the area to that accuracy. 2 points. Well said. Awesome. So this one would have been just, find the area F. They probably would have said something a little bit different, so I would put in your notes these words. They probably would have said, find the area bounded by f of x, the x-axis, and y equals 0 and y equal 4. So that's the wording they would have used in the instructions for the problem, or some wording similar. So your brain says, okay, area bounded by f, so f's the red, so that's one boundary. X-axis is another boundary. Y equals 0, that's this boundary. Y equal 4 would have been here, and that's how I know that the red area is what I'm seeking. Do you need to repeat that or say it differently?
So is this just telling us the subintervals for the Riemann Sum?
No, good question. 2 for Elijah. All eyes on the board, everybody. Look. So this is saying this is related to what Danny said. This is saying nothing about subintervals at all. It's saying what area are you looking for? After they specify what area is to be found, then they would have to specify how. Like what method do you use to find the integral, and to what accuracy should you be computing the integral. So the part about the 4 subintervals, I just kind of did that. They could say something different. Please.
Why is it y equals 0 and y equals 4?
So the line y equals 0 is, oh, that's wrong. How many noticed the mistake? 2 points, should be x.
Okay.
3 for Mikkel. Yeah, that actually just didn't make any sense at all. Sorry about that. Anybody else? Awesome. So another example. Okay, write this on your paper with the other graph. Right, find the area. Bounded by g of x, y equals 0, x equals 0, x equals 3. As you read the instructions, you should be visualizing the space I've highlighted in green. So if you don't see why that's the area we're seeking, just wait and we'll talk some more. Questions from anyone? Okay. To find this area, there's a general pattern here that I want you to memorize. It works for every AP problem I've ever seen regarding area. It always works without fail. You identify the space. Then you simply look inside that space and imagine that you are filling the space with very narrow rectangles. Sometimes it helps to draw a few rectangles. So as I fill that space with narrow rectangles, I notice that the top of every rectangle is starting at the function y equals 0. This is the function y equals 0. That's the top. The bottom of every rectangle ends at the function that we named g of x. So it ends at the function y equal g of x. Okay, the process that always works for every AP question I've ever encountered involving area is to find the area, all you have to do is integrate from the x-axis position where the area begins, so x equals 0, to the x-axis position where the area ends, in this case 3. And you simply take the function that is forming the top of every rectangle, subtract the function that represents the bottom of every rectangle, multiplied by dx, that will find the area. Questions, please?
What does dx mean again?
So dx means change in x, and ideally dx is 0.0001. For the approximations we're doing today, we're assuming that saying that dx is simply 1 is good enough. Okay, 2 points. Please. Hey.
What's the point of the 0 minus dx?
So the reason for the 0 is this. So the next line I'm going to say, okay, I start here at x equals 0. I take 0, subtract g of x. At x equals 0, the value of g is -3. And then multiply that by dx, which in this case is 1. So the purpose of the 0 subtract is to take care of the whole problem where all of these g values are negative. 0 subtract fixes that, because 0 subtract -3 is +3. And I'm able to find the area here. This is going to be a little hard to draw. So I'm finding this area. Without the 0 minus, I'd get a negative number, and I don't want area to be counted as a negative. That doesn't make any sense.
Why didn't you do -4? I guess I'm not following the -3.
Oh, so I'm doing a left Riemann approximation.
Oh, okay.
So I look at the first subinterval and I pick the value on the left.
Okay.
Is that your question?
And would you do that with, you just keep going?
So then we keep going.
Okay.
So the next subinterval, we'll do that in, let's see, blue's good. The value of g would be -4. So I'd have 0 subtract -4 multiplied by 1. The final subinterval I'm doing a left Riemann sum, would be negative, so 0 minus -2. Please.
So what if you find anyone on the top? So let's say on the f of x. If you're using area, would you do 0 minus 2? If you're doing the left Riemann sum, but
so which area are you trying to find? Just point it on your paper, like what area you're looking at.
right, if you're trying to find this area right here,
Like this space here, like we did before.
yeah, and then you're just trying to do that for 1 second, and then you do 0 minus 2 or 0 plus 2, like how would you do that?
Very good, 2 points. Okay, all eyes on the board. Everybody look. Everybody looking. So here's what Danny's asking, and it's a perfect fit. He noticed that to find this area in green, and those 3 rectangles are approximating the area in green. They do a decent job, actually, because this pink one's too small, the blue one's pretty close, the red's a little too big. So they balance out pretty well for the green area. We had to take the y-coordinate at the top of the area, subtract the y-coordinate at the bottom. The y-coordinate at the top is 0. The y-coordinate bottom is whatever g of x is. 1 second, you're good. So he's remembering the other one that looked like this. Okay. Well, in this example, the y-coordinate at the top is f of x. And the y-coordinate at the bottom is 0. So the integral I use to find that area is really the integral from 0 to 4 of f subtract 0. Does I wouldn't take 0 subtract f because I always take top subtract bottom.
Okay.
Is that your question?
Yeah.
2 points, Hadley.
Oh, okay. I was just wondering. So, like, when you're finding the area, you're just finding the side length, right? With this, like, 0 subtracted.
No, everybody, memorize that. 3 for Hadley on
Like
that
a
one.
rectangle.
It's perfect. Listen, hey, memorize it. The vertical distance is found by this formula right here. This is crucial. The dx is the width of the rectangle. Perfect. Please.
So do you just do like, is the second way, I know that they're like the same way, but is it just like if it's below the y equals 0?
Listen to Brennan.
That's how you find it?
The answer is no. It's always the y at the top, subtract the y at the bottom, and I don't care where I'm located.
It just ends up looking just like f of x, but it's on above versus.
If you always just go top, subtract bottom, it always works. And it doesn't matter where the graph is located. Rachel.
Does this find anything different than the total distance traveled?
So now we're not really focusing on total distance traveled per se. We're just finding area.
Okay.
Now it is related. You're right that here this area is a positive value, so it would be the total distance the particle travels to the right as well as the change in position to the right. This one here, because it was a negative area, it would have been either the change in position to the left with this green velocity, or if you count it as a positive number like the area, then it becomes the distance traveled to the left. It's very good. Is that what you meant? 2 points. Mikkel?
If we're finding area, what unit should we put on?
So for the problems where they don't give you any story, you don't have to have units. So because they didn't give any dimensions as inches or meters or whatever, just no units required. 2 points. Solid. So this would become, so that's 3 times 1 plus 4 times 1 plus 2, so that's 9. So my approximation for this area in green is 9. Anybody else? Please.
Is that going to change every time you do a different sum? Like a right Riemann sum?
Yeah, right Riemann sum would be a different answer. Trapezoidal would be slightly different. Midpoint would be slightly different. But you don't need to worry because they'll specify how to calculate the integral. So the big difference, 2 for Isaac, is this. You're learning 2 separate ideas here. One is how to set up an integral to find an area. The second idea is how to compute the integral. Keep those ideas separate because they test them separately. One is you're getting points for the setup and you're getting points for how you compute the integral. Okay? Somebody else had their hand up, I thought. Nope, we're good. Next one. So flip the page over. And write this on your paper. Write, find the area bounded by f of x, g of x, x equals 0, and x equal 12. Well, let's just go to, we better go to 12. Got to make a point here. Okay. Raise your hand if you can visualize what space I should highlight to match the written description. So read the instructions. Raise your hand if you can visualize what space I should highlight so I match the area they're asking me to find. Feel free to talk to each other. So right now you don't worry about anything other than just the instructions on what area are they specifying. So when they say the area is bounded by, those areas form the fence, the boundary of the area. You don't worry about left or right Riemann sum because that's how you find the integral. This is the part where we're just setting it up. So we don't care about that yet. Good question, though. We just want to make sure we highlight the correct area. It feels like they know how to highlight. Show me your hand. Yeah, who feels like they know how to highlight? I'm going to do it. If it's right, you can take points. Just be on it. So I would continue with this green highlighter. Yeah, that's a little large. Thank you. So I highlight that space, and then we continue with this space. This is where you try to withstand the temptation to finish the highlighting. Sometimes it's successful, sometimes it's not. It feels so nice to just, flow. I can feel the peace in the room. It's not the best job in the world, I apologize. My hand gets in the way, I can't see the boundaries in some spots there. Plus, if I ever lift up my pen, it doesn't look very nice. As soon as you lift your pen, the color changes. Spoils the peacefulness. That's not too bad. Who was visualizing that? Show me your hand. 2 points. Have it.
Okay, so because, you know how you said you do the top minus bottom? So because the top and bottom change, you have to do 2 separate intervals?
Mm-hmm. Perfect. 3 points for Hadley. So we do integral from x equals 0 to x equal 4. The top function would be f. Subtract the bottom function g. Then we continue integrating from 4 to 12, but now as Hadley says, the top function is g, the bottom function is f. Question? If you need me to repeat anything, just wait. So in this section, which begins at x equals 0 and ends at x equal 4, the function that is forming the top of every rectangle is f. The function forming the bottom of every rectangle is g. So that first integral is f subtract g. But then I've got to still find all of this area, which begins at x equal 4, ends at x equal 12. So I integrate from 4 to 12. Now the top of every rectangle is formed by g, the bottom by f. So I switch it. 2 points for Cass. Anybody else? Please, go ahead.
So for this one, would it be possible to add an area bounded also with the y equals 0? Or is that, does that not work with the f of x like g? It's like, can there only be 2 things that bounded, or can there be 3?
They could have made it more complex, I suppose. In this case, I just wanted this example because it's common. 2 points. Did that answer your question?
Kind of. Just like, I don't know. Like, if it was y equals 0, what would happen to the boundary?
It's a little confusing to say those boundaries and also y equals 0. So I don't think they would do that. It becomes a bit ambiguous. But 2 points. Anybody else? Awesome. So I'm going to calculate the integral now using a left Riemann sum. I go to the first subinterval, and I pick the left side. So the value of f is 2. That's what it says, f. Losing Allison today. Pull out your headphones, please. So you're okay. You just didn't notice. The value of g is -3. And my top minus bottom trick works perfectly because 2 subtracted -3 is 5, which is the vertical distance for this first rectangle. So the integral will find that area like so. Then I go to the next subinterval, multiply by the width, which is 1. So for the next subinterval, the value of f on the left of that subinterval is 5. The value of g is -4. So I find that area. So 5 subtract -4 gives me the correct length of the rectangle, which is 9. So we want to talk about any of that. Raise your hand if you know what I'm going to write next. Just raise your hand if you know exactly what I will write next. So Sarah?
6 minus -2.
6 subtract -2 multiplied by 1 correctly finds this pink rectangular area. How many know before Sarah said it? 2 points. Okay. You want to wait and have me repeat anything? It gets a little tedious to keep going. I can keep going if it helps you, but I don't like to just do busy work if you're all like, yeah, I got it. So wait, if you want me to do another one? I think we're good. Okay. So the big idea again is this. Every time you are asked to find area, it's very simple. Identify what area they're referring to. Figure out if you fill that area with rectangles, what will the top of each rectangle touch? What will the bottom of each rectangle touch? We integrate top minus bottom. That's it. Please.
How do you know which Riemann sum to use?
So no worries, 2 points for Maya. So that's that idea that there's 2 parts that you're thinking and keep your thoughts separate. One part is how do I set up the integral? Second part is how I compute it. So everything I just told you is just the setup. Identify the area that you need, draw the rectangles, identify where the top of each rectangle touches, where the bottom of each rectangle touches. That's just the setup. They'll give you separate instructions for how to compute the integral. So here we've just been doing left Riemann sums because you're familiar with it, but they could ask for any type of Riemann sum. Or
So could the bottom of the rectangle, like, could you put the first one at 5 and -4, or are you doing, for setting it up, are you doing the leftmost?
for setting it up, what I'm doing is drawing, this is a really good, 3 points for mine. For the setup, I'm envisioning infinitesimally wide rectangles. So for the setup, I'm picturing rectangles that look like this. They're very narrow. And just paying attention to what does the top of each rectangle touch, what does the bottom of each rectangle touch. It doesn't matter where I draw a rectangle, the top's always going to touch F. Doesn't matter where I draw a rectangle, the bottom's always going to touch G. So that's how I create the integral here. When I get over here, every rectangle, no matter how narrow, the top of every rectangle touches G, the bottom touches F. So I'm not thinking Riemann sum at all yet. Did that answer your question?
Yes.
2 points.
So then the f of x minus g of x part is totally accurate. The only part that isn't is the width that you have that.
It's perfect. It's perfect. This integral, Maya and Avery and everybody else, this integral, if I could get rectangles that were a width of 0.00001, it would find the area perfectly. No error. So the setup has nothing to do with Riemann sum at all. Riemann sum is how I compute the integral.
How would you do that? Like, see, like where the yellow lines are. How would you do that column?
Not sure. Say
So
something.
like you know how you just did like you. I know you said don't worry about Riemann sum, but you just did those first three in the left Riemann sums, you know. But like after the 4, how do you do that column? Because they're both like kind of right there.
Are you talking
Does that
about?
make sense? So like if you kept going, so you know how you stopped.
Uh-huh.
You kept going, it would touch at 5,
Oh, so
and then to 0, and then. But what would the next one be?
I'm going to guess what you're asking. If I'm wrong, just tell me again, so you understand. So I'm not sure. If I were doing this integral, I think what you're saying is if I were doing this integral as a right Riemann sum, I would look at the first subinterval, 0 to 1. I would pick the value of f on the right, which would be 5.
No, yeah. No, I'm asking. So like you see the 4, the marker 4.
The 4 right here?
Yeah. Go like with the column right next to it to the right.
Right
How
here.
do you do that one?
Oh, I gotcha.
Because they're like kind of both touching.
I think I know what you mean now.
Is it just like is it just like?
So let's keep going for a second. I think you'll see it. So let's pay some extra credit. So we've already done the blue, we've done the red, we've done the pink. Let's switch to purple. So I want to do, this is the integral that goes from 0 to 1, or sorry, the computation that goes 0 to 1. This is the computation 1 to 2. This is the one 2 to 3. I now need to go 3 to 4, and then I want to go 4 to 5. So hands up if you know what gets written next. Show me. Hey, everybody. What do I write here as I'm continuing the, this is what Brennan's asking about. Tristan.
5 minus 0.
So looking at this subinterval, the value on the left is 5. That's the f value. The value of g on the left is 0. So that will calculate this rectangular area. So this would be 5 subtract 0 multiplied by 1. How many knew it? Show me. 2 points. Okay, that would finish the left Riemann approximation of this integral. Now we'd be working on this integral. So we'll go back to blue. For this first subinterval, I take the value of the value of g, subtract the value of f. It's going to look a little silly, but so if it looks dumb, you're understanding. But hands up, what gets written here? You just follow the instructions. Value of g, value of f. What goes here, Mikkel?
0 minus 0.
0 minus 0.
3 minus 3.
Oh, thank you. It is 3 minus 2. The result is 0.
Yeah.
Yeah, my bad. So who knew that this would become 3 subtract 3? Show me that. 2 points. So there's no rectangle that I can draw there. There's nothing. It has a height of 0.
Okay. And then it would be like 5 and 2. Okay.
So then the next one would be, say it, Brennan.
5 and 2.
Yes, thank you. So the 5 subtract 2 would correctly compute the height of the next rectangle, which needs to be 3. So as always, my approximation's a little off. Like I don't get anything for this yellow area here, but it kind of self-compensates as you keep going a little bit. Is that your question?
Yeah, I just didn't know, like, you draw a line there because it was just like,
Nothing really to draw. You can draw a line or just leave it blank. It doesn't matter.
Isn't it 2 subtract 5?
So we're here now.
Yeah.
So they switched places, so the g function's here. No worries. 2 points for Allison. Please.
So how do you do a trapezoidal form on this? Could you just show us how you find the area of trapezoidal?
So I'll kind of just jump over to like this next section because it's hard to erase that. Trapezoidal, you would take for this say this subinterval here. You take the value on the left. So like that. Then you go value on the right as well. Like that. Then they connect like so.
So it's a parallel.
They do. Does that make sense?
Okay.
Please.
So you know where like f of x and g of x cross, and there's like kind of two sections, kind of. Is it possible to use, so you use left Riemann sum on the left of that? Is it possible to use the right Riemann sum on the right of it, or do you have to use the same one throughout?
Really good question, 3 for Ashley. It's possible, and it actually makes logical sense to perhaps do it that way. They won't, I feel confident, they're never going to ask you to do that, I don't think. They'll just say one method.
Because, yeah, how I was looking at it, I just thought you would use the right Riemann sum for some reason.
It's
But-
because visually you kind of think it fills in the space better, but you don't ever have to worry about that part of it. They'll just specify it. So,
Okay.
good question. Superb. Outstanding. Are we good? Okay, grab the pink. Okay. This entire unit is all written questions. So we're now practicing FRQs. This entire unit is calculator allowed. So we're also practicing the calculator type question. To get points on the written section, you've got to learn to write effectively. And in some cases, they're not picky at all. In other cases, they're very picky. But I would argue strongly that usually when you think they're picky, it's because what you wrote makes no sense. Like, what you write has to make sense. For example, I'm indicating that this point has an x-coordinate equal to, I just call it a since I don't know the value yet. So you need to specify whether you're talking about x or y coordinate. It wouldn't make any sense to just point to a dot and say a, because you're not telling the grader whether it's the x or the y. But you need to repeat that just wait. So make sure you're specific. I did the same thing here. I'm interested in the x-coordinate at those points, not the y-coordinate. So when the grader looks at my work, he can see clearly what I'm talking about. Don't just draw an arrow and say B. That is not going to get you the point. Okay? It is really good practice to label your functions. So they said this one is tangent x, and this one is 2 minus x cubed. Well, I like to have the top function be f, the bottom function be g, even though they switch at times. So I'll just look and say which one is kind of starting on top, which one is starting on bottom, and I label them as such. So this is the top, that's my f, and the other one's the g. Do not do this. Don't do this. You have to make a new statement. Don't do that. Just write it out for the grader to see it. Questions? The next test will be graded like the AP test, so it will be graded by a grader who will examine to see if you are using the right kind of notation. So, good? Awesome. Okay, we're supposed to find, it says here, R and S are the regions in the first quadrant shown here. Region R is bounded by the x-axis and the graphs this and this. So they give a description. So this part here, all FRQs on the AP Calculus test begin with a piece of information. There's never a question within the information. It's just data. So you never have to look for a question in that box. It's just always information. The questions on the FRQ are always labeled A, B, C, D. So we identify the question, find the area of R. So my highlighting kind of hid it, but R is the red area here. Wave if you need me to give more explanation as to how I knew that the red area was R. Cool? Okay, to find that area, I use the same technique we just talked about. I draw narrow rectangles within that space. Raise your hand if you can see why I decided to change from blue rectangles to yellow, and why I decided to change where I changed. So I filled the space. I started doing blue rectangles. Then I said, oh, got to change. I'm going to do yellow. So why did I change from blue to yellow as I filled the space R with vertical rectangles? Feel free to talk to each other. I want everyone to see this. Why am I changing from blue to yellow? Hands up. Who knows? Why am I changing from blue to yellow, Isaac?
That's the point where it starts becoming bound by S rather than or by the tangent of X rather than 2 minus X.
No, very good. So again, I look at the blue rectangles and I say the top of every blue is touching G of X. The bottom of every blue is touching Y equals 0. So in the blue section, I know that the top is G of X, the bottom is 0. So G of X subtract 0 is just G of X. I always find area by going top minus bottom. How many noticed that? 2 points. Anybody want me to say it again? Just wait.
On the AP test, do we have to clarify that we're finding, like how you wrote area of R, are we expected to write that statement?
You do not have to write that statement.
Okay.
If you simply write the integral, it's good enough.
Okay.
Good question. 2 points. Elijah.
So, one second, I need 1 second.
You're good. So then, in the yellow section, the top of every yellow rectangle touches the function f of x. The bottom of every rectangle touches the function y equals 0. So the second integral is f of x subtract 0. Questions? Please.
Is the like x equals a and x equals b, like putting those points there, like something that you end up doing a lot in these types of problems, just because it's a way for you to tell what like spaces you're kind of using?
No, it's very good. 2 points for Brennan. Hey, look, I noticed that to find the area of all the blue rectangles, I have to start at x equals 0, and I have to stop at whatever x coordinate this is. Okay, so I'm going to have to find that x coordinate. We're going to use our calculator to do that, but we're a little short on time today, so we'll wait. But I'm going to find it, but just labeling it as A allows me to keep thinking. I'm like, okay, no big deal. I can find that on my calculator. Then the second integral has to start at x equal A and end at x equal B. You need me to talk more about that. So all we're doing is the setup. We're not doing the integral yet. We're just setting up what integral is needed to find the area they requested. Okay, cool. Now let me show you how the scoring works. So you turn to the back. You notice they didn't use the labels F and G. Look, use the labels F and G. It is going to save mistakes in the future. It'll prevent errors. But you can write either one. You can write it out, or you can just write F and G. So here's my G function, here's my F function. They said one of the limits is A, and then they solve for the other limit. We'll just find both of them on the calculator. That's easier, and you get the same points. The way the points are awarded is you get 1 point if the limits are correct. So all 4 limits are right, you get 1 point. Okay, watch my pen. Everybody, eyes on the board. Okay. This entire thing right here that I'm circling, that's the integral. The stuff inside is the integrand, including the dx. So if I have the integrand, I get 1 point. And I've got both of them. Then if I can correctly type it all in my calculator and get the right decimal, I get a 3rd point. Okay? Questions? Please.
Do you have to get all of them right to get 3 points?
No, so you can get 1, 2, or 3 points. Is that what you meant? Yeah, they'll work partial. 2 points for me. Okay, listen close. The homework, like I don't want to have homework over the break if we can help it. So there are only 11 problems in this packet. They're all to be done with your calculator. So they go pretty fast once you understand how to do the setup. And the next time I'll show you how to answer it in your calculator to get the computation. So you don't need to worry about that yet. I'll show you next time. But if you want to get a head start on this packet, not every problem, but most of them have a picture. And with the picture, you can actually do the setup already, like I showed you today. So if you want to get a little bit of a head start so you have no homework over the break, if you want to do the setup portion of this packet, you can do that. And you can check the back to see if you're setting it up right. And then we'll do the calculator part next time. So next time we only have 38 minutes, so it works out pretty well. Just have to show you how to use the calculator.